LRO is this amazing spacecraft that has 7 science instruments on it that's been in orbit around the moon since June of 2009. And it's collecting all sorts of data to help NASA make really good decisions in the future about where to send robotic spacecraft and humans, and to address fundamentally important science questions, not only about the moon, but about the solar system in general. I'm Mark Robinson, and I'm the principal investigator of the Lunar Reconnaissance Orbiter camera. Okay, what is LROC? That's a great question. Sounds like one camera, Lunar Reconnaissance Orbiter camera, but it's not. It's actually 3 cameras. There's 2 identical narrow-angle cameras that are very high resolution. They're pixels about this big, 50 centimeters, and it was designed so that you could look at a human scale on the surface to find safe and engaging landing sites. Then there's a 3rd camera, a wide-angle camera, which is literally about this big. It maps the moon in UV and visible wavelengths, and its key purpose is to look at compositional differences for both scientific and resource evaluation. It's not easy to find new impact craters because most of them are very small. The only way we can really do this is we have a before image and an after image. And we've been in orbit for 4 years now. So what we're doing now is we're going back to images that were taken in the first year or 2, put them on a computer screen and blink them. And then it becomes really obvious, oh look, there's a new crater there because it wasn't in the before, it's in the after, before, after. And we call these temporal pairs. So now we have several thousand pairs. And to sit down and look at every single pixel in all those images would probably take one person, 10 or 20 or 30 years. So we started working on an algorithm or a computer program that searches the images by using a little template, the before and after pairs, and it automatically finds them. It gets like about a 90% success rate. So far we found hundreds of changes on the surface. Many of them are too small to really know for sure if they're craters or if they're secondary craters. But we have found over 25 that were absolutely positively confirmed craters. You can see the rim and the ejecta. And we've also made this amazing discovery that we find secondary craters related. There was a bright flash that was recorded by a video camera by a team at Marshall Space Flight Center. And it was the brightest flash they recorded, so it must be therefore one of the biggest craters. And so they were really interested for us to take a picture. Can you see the crater? Because they predicted how big it was going to be based on the energy, but this is all a model, and so it's a great opportunity to actually calibrate their model. So we took a picture centered on their coordinates, and we didn't find a crater. We found these enigmatic little splotches. There was something disturbance of the soil that wasn't in the original image, but we didn't know what it was. So we thought, okay, well, their coordinates were off a little bit because their pixels are really big from their camera. In fact, their pixels are bigger than our image footprints. So I said, okay, no problem. We'll move over to the west and we'll take we're building up a mosaic. So next month comes around, we take a picture and we do the same thing, look at the before, look at the after image, no crater. But more of these splotches. But also in that image, we saw what looked like very faint rays. And we thought, boy, I wonder if those are actually rays from a crater. So we just did the simple exercise of drawing lines and see where they converged. And then, so the next month we came around, remember this is the 3rd opportunity, we center the field of view of the camera right on that latitude, longitude, boom, take another picture, comes down, and there it is. Beautiful 18-meter diameter crater. And then we started looking at, now we've got 3 of these, and there's hundreds of these little splotches that we're finding, these rays. And then we had the big picture. We could see that the splotches are actually lined up. These very small clods of ejecta were thrown out 10, 20, 30 kilometers away. That's 30,000 meters compared to an 18-meter diameter crater. So it's a very exciting discovery.